Hi children, good afternoon. Today we are continuing the chapter 9, and circle. We say the circle in the last. Let me share the screen. Look here. You can see here. Class name mass. It also here. Circle continued page 122, 129. You can see exercise there. Exercise 9.2. We did that one. Now, minor arc and major arc. Equator circle and congruent circles are equal, then their corresponding angles, arcs are congruent. Then converse congruent arcs or equal arcs of a circle subtend equal angle at the center. A circle, congruent circle also, congruent circle is same circle. Angle in a semicircle is right angle. Then lower come. What is minor arc? What is major arc? I think there is no confusion, minor arc and major arc. Look, a circle. Here, suppose. Arc of the circles are made by what we can say. When you are cutting a circle, you are getting many arcs, right? Small arc is the minor arc and big arc is the major arc. What is that? Look here. This is a circle. So I am cutting here. This is an arc AB or BA or BC arc BC. Two arc I can say. Many arcs are there. This is BAC. I am taking this arc BC. This is a minor arc BC. Major arc also BC. For avoiding the confusion, I can make BAC, the big arc BAC. Each of a circle. If you want, we can put here BXC. BX is the minor arc and BAC is the major arc. So I think minor arc and major arc, you understood. Now angle made in the center. This is the center made, the angle. BOC is the angle made the center. It will be double of the angle made on the segment, I can say, other part of that we studied. Now look here, the angle subtended by an arc at the center, double the angle. Okay, that is coming here. Before we studied minor arc and major arc. Angle made by minor arc is BOC, and angle made on the segment. This is called BAC, the arc, and you can see the segment here. You know one part here. This is the segment. Other part of the circle, BC the arc, and BAC the other part of the circle. Now listen, please, listen here. Here, I think you understood minor arc and major arc. Now come to the point here, please. If chords of a circle or congruent circles are equal, or congruent circles are equal, then their corresponding arcs are congruent. If chords are equal, what they tell you? Look here. The chords of a circle or congruent circle are equal. One circle is here. Chords of a circle. One chord is here. Then the corresponding arcs are equal. Nothing. Chords are equal. Suppose this chord and this chord. AB is a chord and CD is another chord. Then we can see the arc is this is the corresponding arc. CYB, AXB. If this is 7 centimeter, this is 7 centimeter, chords same, chords are equal. Then their corresponding arcs are congruent. CYB congruent to AYB. That's all. Okay. Now, listen. Congruent arcs or equal arcs of a circle, congruent arcs, equal arcs of a circle subtend equal angle at the center. What is it? Before the chords are equal, if chords of a circle or congruent circles are equal, then the corresponding arcs are congruent. Convex, congruent arcs of a circle subtend equal angles at the center. Clear. Angle in a semicircle is right angle. Fourth one I am talking about. In a semicircle. Angle in a semicircle is an you can draw a semicircle. I am drawing a semicircle. Angle in a semicircle. I can show here. This is a circle. You know, semicircle is the diameter, is the chord. There is a semicircle. Angle by a semicircle. You know what is this? This is the angle made by semicircle. This is PQ, the chord PQ. This is the center. So angle made on the segment, because you know this is 90, 180 degrees, right angle. So it is 90 degrees. Look here also we can draw many angles. Here PRQ. This is PTQ, suppose. Angle PRQ is equal to angle PT is equal to 90 degrees because angle in a semicircle. What is the diameter here? This diameter making an arc. This is the arc, semicircle is the arc. Another part also semicircle, it is 90 degrees. That means this is 180 degrees. 180 plus 180, 360 degrees. 90 plus 90. Okay. Clear or not? Okay, fine. Then come to the main point. These are the revision of what I did. Theorem. There's only two theorems here in this part, in this module. What I can say, theorem 9.7, 9.8 is the Conway's 9.9. Up to 9.6 we studied. It is easy, but this exercise is very interesting, not boring, not lengthy theorem. See the theorem. The angle subtended by an arc at the center is double the angle subtended by it. Any point on the remaining part of the circle. What is the theorem? The angle subtended by an arc at the center is double the angle subtended by it at any point on the circle. Look. Understand? Read it again. Same thing from the textbook. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Remaining part I told before. So arc is the chord is the remaining part, other part. Semicircle service. Now we can see. Let me. The angle subtended by arc. Center is double the angle subtended by it at any point. Let me write on the top of it. Listen. The angle subtended by arc at the center. This is the circle. You know, arc is a part of a circle. PQ, this is the arc. And angle made in the center. Suppose this is X, the angle is X. It will be double of this, double the angle subtended by any point on the remaining part of the circle. That means this is the arc. PQ the arc. There is a chord, you know. This PQ is the arc. Then any part, remaining part of the circle. Look here, listen. Let me draw another circle. Here almost. Anyway, circular, all circular like this. I don't know why like this. I'm very poor in drawing. Almost. Here is the arc AB or PQ. PQ is the arc. This is the center. Angle made in the center. This is the angle, center angle. Suppose this is 80 degree. Suppose. So we know the arc. This is the arc. And remaining part of the circle, can you see I am joining this one? I can join here, this angle, or I can join this one here. From the arc only, arc here it is O is there, and I am joining OQ. Then O, what is this P? This point. From here to here. PQRS. Angle made at the center is 80 POQ. So I can say this is 40, half of 80. Sorry. This is 40 and this is 40. Angle made by the arc at the center is double the angle made at any point on the remaining part of circle. Anywhere. Remaining part of circle is anywhere you can make. Angle. I can make here. It must be from here P to like this. PQRST, this will be 40. That is what. Understand the area. Look here. Here. This is the angle. Understand? This is a triangle. Here you can see another angle. 80, 40. 80, 40. 80, 40. Okay. So now look the example. 3 conditions. You can see, look, 3 conditions are. What are the conditions we can check? The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part. Now, arc PQ is given. You can see arc PQ. Arc PQ here. PQ. Subtend angle POQ. You can see POQ here. You can see the center POQ. Yes. POQ is the angle. Angle POQ at the center and remaining part of the circle. And PAQ, POQ and PAQ, you can see here PAQ. We need to prove that POQ is equal to 2 PAQ. PAQ in the double and POQ. That's proved here. For that, what you have to do? PQ is a minor arc. It is clear PQ. Join AO and extend to point B. A to centrally join with AO. Now B is not extending. Okay. Now what we got? What is Shaddika? Three cases. One is the minor arc. PQ is the minor arc. Second is PQ is the semicircle. And third PQ is the major arc. 3 conditions. In 3 conditions, we are using the exterior angle property. Look here. BOQ, listen, BOQ, angle BOQ. What is the angle? BOQ angle. That is equal to QAD, small angle, and AQO. Because this is only because exterior angle of a triangle is equal to sum of two interior opposite angles. Exterior angle property, what we studied before. Exterior angle of a triangle is equal to the sum of two interior opposite angles. So please understand the property. Now what we are, I will show that. OA is equal to OB, OQ. That means two triangles radius, isosceles triangle this one. Radii of two circles. Therefore, OAA, what is OAA? The small angle is equal to BQA. In isosceles triangle, opposite angles are equal. Yes. QA, that means okay. OAQ is equal to OQA. OQA. Where is O? OQA. Therefore, this gives BOQ is equal to 2Q. Therefore, 2OAQ. OAQ. Under 2 times can be BOQ exterior angle property. Similarly, we can say BOP. Here, you can see BOP. BOP angle is 2OAP. 2OAP. From that we can see, we can add 2POP. We can add POP, QOQ, that means 2AP, 2OB. That means POP, POQ is equal to 2 times PAQ. 2 times PAQ. Listen here. This is the second case, what I told you, PQ, you can see the PQ, this is the PQ, it's a semicircle. There also you can prove that angle made in the center, here angle is 180 degree. That is why it will be 90 degree. Double or 90. And here it is, what we can say, it is the reflex angle, or what I can say, major arc, major segment. So here the angle made, it will be reflex angle. For that, PQ major arc, a reflex angle, plus again the reflex angle. We know reflex angle. In the theorem 9.7, A can be any point on the remaining part of the circle. So if you take any other point C on the remaining part of the circle also, you have another point also you can take. 1, A, B, A, C. It will be same, it will be half of this one. That is why next theorem angle in the same segment of a circle are equal. I think confusion is there. Confusion down. This theorem is important and choice. Angle subtend and the center is double the angle at the remaining part of the circle. That's a question. Look, here are two things I can tell you very clearly. You have to understand that. What is that? Look, I will try. Here, I am taking this triangle outside. It's a collateral actually inside the circle. Here, One is here. Another. It is no radius. Then after that, what is you can see here? This is A. This is P. This is Q. Look the figure, all of you. Now this is the center of the circle. Oh, a line passing through the center. This is a line I am drawing this sign, and I am extending this one. This is going on. Now here in the center from P, you are joining from here also. You are joining. Yes. Now this point is P. Okay. So what is happening here? You can see a triangle here. Triangle property. Exterior angle. I can say this angle 1. This is exterior angle. Exterior angle will be equal to sum of the interior opposite angle. Angle 2, 3. Angle 1 is equal to angle 1. That is equal to exterior angle is equal to sum of the interior opposite angle, not adjacent angle. Interior opposite angle. No, not like this. So angle 1 is equal to angle 2 plus angle 3. Many times I told you, don't say 1 is equal to 2 plus 3, sir, for now. So exterior angle is clear, I think. 1 plus 2, 2 plus 3. Again, I am taking this triangle. You can see this side. Second, I am taking this triangle. Here you can see one triangle is there. Here. And this is the exterior angle. Here I am giving one name for this exterior angle. 1, 2, 3 is 4. Suppose this is 4. This is 5, 6, 7. Okay. Here also I can say angle 5, that exterior angle is equal to angle 6 plus angle 7. There is no doubt. Now before that, angle 1 is equal to angle 2 plus 3. Yes. Now look, you can see the beauty of math. Now it is a circle. This is inside the circle. Circle I cannot draw now. I am very poor in drawing, I told you. It's a circle. Anyway, what I want to show you here. This is the radius of the circle. This is the radius of circle. This is an isosceles triangle. In an isosceles triangle, see, because the radius, this radius. So, angle 2, that is equal to angle 3. Yes. In isosceles triangle, 2 sides are equal. So, opposite to that, 2 angles are equal. So, angle 2 is equal to angle 3. That means angle 1 is equal to angle 2 plus angle 2 is equal to angle 3. Angle 2 plus 2 angle 2, that means 2 angle 2. Understood or not? Angle 2 plus angle 2. 3 means 2. This angle 3, I can give this one angle 2. Angle 2 plus angle 2 means 2 times angle 2. Clear? Or before that I am writing here, angle 1 is equal to angle 2 plus angle 2. That means 2 angle 2. X plus x is equal to 2x. Mango plus mango means 2 mangoes. 2 angle 2. Correct. There is no confusion. Yes. Now here also similarly we can say what I told. 5 is equal to angle 5 not angle 6 plus angle 7. That means 2 angle 6. Because 6 is equal to 7, same property, radius. You are a radius, I am a radius. So it is isosceles triangle equal. If you are reading the textbook, you will feel that is hard. So take it separate, together they are talking about. So here what I wrote, angle 5, that is equal to 2 times of angle 6. Now look the figure, all of you. This is equation, this is equation 3, this is equation 4. Suppose this is equation 4. Now from here, what we can say, from 3 and 4, what we put? Now 3 and 4, from 3 and 2, I am adding from 1 and 2, like that I am adding. Look, angle 1 plus 5. 1 is from angle 1, and simply adding angle 1. This is angle 1 now, angle 1. This is angle 1, I am marking here. Angle 1. This is angle 5. And this is 2, small angle 2. This is 3. This is 4. This we don't want. Don't confuse. Now here it is 6. And here it is 7. 5 plus 1, I need the central angle. This big angle, see, angle, this I am adding 5 plus 1. Or angle 1 plus 5. Angle 1 plus angle 5 is equal to, here see, angle 1. What is angle 1? 2. No root to 2 angle 2 plus angle 5 is 2 angle 6. I think it is clear. Yes. Now what is angle 1 plus 5? What do we need? That is POQ. We reached. Therefore, angle POQ. We need to prove that angle POQ, this one, to angle PAQ. Angle, you have to write angle PAQ. POQ. Dear children, please tell me, please. You have to tell. I am talking. Angle POQ. Angle POQ, that is equal to PAQ. Yes, sir. Angle 2 plus angle 6, that means PAQ. PAQ. 2 is there. This angle 2 plus angle 6, that is equal to angle PAQ. We got what we need. We got it. Okay, that is what. Look. Now look here. Look. Here we can see. Same thing. Let me write this one. ഇത് മനസ്സിലായില്ല ഞാൻ ക്രാസ് ചെയ്യാൻ പാടില്ലെങ്കിൽ അത് എല്ലായിടത്തും പോയിട്ട് കൺഫ്യൂഷൻ ഉണ്ടാവും. Now look here. Same thing. Exterior angle property. Exterior angle triangle is equal to, because I gave the number instead of angle 1, 2, 3. You can give the number. None you would carry. 2. From 1 and 2, 2 times angle 5 and 6. That means we got the angle 2PX. This is same as 2PX. Now here, second figure, you can see exterior angle is BOQ. Here also same angle, same triangle. Isosceles triangle, radius, we are getting the same thing. But one more thing, let me add here. In a semicircle, angle will be 90 degrees. Because this angle made in the center, that is 180 degree. After 180 degree means 90 degree. Now, it is semicircle. Here, RPQ is a major arc. Can you see PQ? PQ like this. If you want PSQ. not PQ, this one, these are, see, here also center is the line segment is the, we can see the angle here, this angle plus this angle because equal radius, both are radius, then same thing we are making. In examination point of view, prove one, first case, minor arc. Then we can see. For here PQ is a major arc, 3 is replaced by POQ reflex angle. Here reflex angle ആണ് reflex angle. POQ not inside, outside reflex angle. ഒരു property കാണാൻ പറ്റും. When the major arc, see, here the major arc, the arc is big. What happened to the angle? Angle also big. Arc is equal, and small arc, that means the small center angle, then angle inscribed in the other part of the circle, that is called inscribed angle, center angle, don't confuse that. So again, I am reading the theorem, I think it is clear. The angle subtended by an arc at the center is double the angle subtended by it, any point on the remaining part of the circle. That is stress. Again, the angle subtended by an arc at the center is double the angle subtended by it, any point on the remaining part of the circle. Remaining part of the circle, PQ. You will see PQ. No, this is PAQ. This is the minor arc. Now this is the major arc. Here, this is the semicircle. Both are PQ and PAQ are same. But here, major arc, PQ the major arc, PAQ the minor arc. That you understand the difference. That's മനസ്സിലായെങ്കിൽ അതിന്റെ converse. അതിന്റെ തന്നെ in theorem can be point remaining part, any point. Converse no. And PQ is equal to PAQ. Again, PAQ is equal to PCQ because center angle half. I told you if it is x, it will be x by 2, x by 2. If it is 100, this will be 50 and 50. Another many we can draw like. This is very important. ഒരുപാട് question base ചെയ്തിട്ടുണ്ട്. Especially in the exercise, we can see it is the 9 exercise 9.3, I think so. New book 9.3. There are 12 questions are there, but all questions, especially the figures, are given very easy. Other you had to draw a figure and the Christmas exam tomorrow, some exam is there, I think so, some of the school Apex, something like that. Hard question ചോദിക്കണം മക്കളെ. Okay, you can refer this one. That is why I'm doing this today, because yesterday night I did for other children. ഈ വീക്ക് കുറെ കുട്ടികൾ വന്നിരുന്നു, കുറെ കുട്ടികൾ ഓൺലൈൻ പ്ലീസ്. അവരൊക്കെ ചോദിച്ചു എക്സാം പാസ് പേപ്പേഴ്സ് ഉണ്ട്, പക്ഷെ അതിനിപ്പം സെൻഡ് ചെയ്യുന്നില്ല മറ്റ് സ്കൂളുകളിൽ. They sent to me. Only 40 mark question. No? Okay, right. Now listen here. ഈ തിയറം ഒന്ന് ശ്രദ്ധിക്കുക. Angles in the same segment of a circle are equal. Angles in the same segment of a circle are equal. Same segment in a circle, angles in the same segment of a circle are equal. The segment ആണ് ഇതിൽ വരുന്നത്. സെയിം സെഗ്മെന്റ് ആണ്, സെയിം സെഗ്മെന്റ്. C, D ഒക്കെ ഉണ്ട്, അതൊക്കെ ഈക്വൽ ആണ് അർത്ഥം. ബിക്കോസ് മൈനർ ആർക്ക് ഓർ മേജർ ആർക്ക് എവരിത്തിങ് ലിസ്റ്റഡ്. Okay. Now here, before the starting, I told you angles in a semicircle is right angle. Chords of a circle, congruent circle are equal chord make. Their corresponding arcs are congruent. Abhi arcs are congruent. Chords are congruent, equal. Chords are equal means arc are equal. That means same angle, all are related. Comparison. ഒരുപാട് ക്വസ്റ്റ്യൻ അങ്ങനെ വരുന്നത്. ഓക്കെ, ഇത് പിടി കിട്ടിയോ? അത് ഈ അണ്ടർസ്റ്റുഡ് യെസ് ഐഷ, യെസ് രാജി, Okay, fine. You understand. Now, next one. We are talking about cyclic coordinate. Please attach that your mind and detach unnecessary things. New things are chord, angle in a semicircle, angle subtended at the center is double the angle subtended at the remaining part of the circle. Remaining part of the circle. Arc is the without the arc, remaining part. Arc means a piece of a circle. Remember your bangle, or father or mother's band. Now, cyclic coordinate. What do you mean by cyclic coordinate? Think about cycle, okay, circle. Yes, cyclic coordinate. Okay, we can think about now. Please. Then only I will explain. What is cyclic coordinate? Please, all of you, please. Okay, ready-made answer. You will tell I know. That means cyclic quadrilateral means cyclic quadrilateral. I am drawing here. We draw anyway. Cycle. Ah, yes, that is cyclic circle. My circle is always like this. I don't know. Listen. Very nice. It is here. Circle. Now, what do you means? I need sorry. Yeah. Yes, sir. Circle is there. A quadrilateral A, B, C, D. I know your answer is like this. A, B, C, D. It's a quadrilateral. A quadrilateral inside a circle. Yes. A, B, C, D. So this is the cyclic, correct? It is cyclic quadrilateral. How can we check this very fast examination, whatever you have to draw a circle and check cyclic quadrilateral. Another method is there. If it is a quadrilateral, yes, it is a quadrilateral. If opposite angles are add up to 180 degree. In a parallelogram, not talking a parallelogram, opposite angles are equal. These opposite angles add up to 180 degree. Suppose this is 70, this is 110. So we can say 70 plus 110, 180. If opposite angles of a quadrilateral add up to 180 degree, that quadrilateral called cyclic quadrilateral. Sum of opposite angles of a quadrilateral 180, not adjacent angle. This also, we can check D plus B. D plus B is equal to 180 degree because two triangles. We are cutting, we can quadrilateral into two triangle, we get it. Okay. That is what I am talking about, cyclic quadrilateral. I think you understood. Okay. Now listen here. Listen. Cyclic quadrilateral. I am talking about cyclic quadrilateral. I drew the cyclic quadrilateral. Then If a line segment joining 2 points subtend equal angles at other point lying on the same side of the line containing the line segment, the 4 points lie on a circle. What is it? If a line segment joining 2 points subtend equal angles at 2 other points lying on the same side of the line remain in the line segment, the 4 points lie on a circle. They are concyclic. ABCD is called cyclic. All 4 vertices of lie on a circle. That is the first definition. Lie on a circle. Okay. Concyclic, it is called concyclic. If a line segment joining 2 points subtend equal angles at 2 other points lying on the same side of the line segment, then the 4-point line on the same circle, they are called concyclic. This is concyclic. I call that ABCD is called cyclic. If all the 4 vertices lie on a circle, here ABCD is a cyclic order. I think it is understood. Textbook definition and then add before us. Now come to the theorem. The sum of either pair of opposite angle of a cyclic quadrant is 180 degree. The cyclic quadrant, then we can say angle A plus C is equal to 180 degree, angle B plus D is equal to 180 degree. Sum of pair of opposite angles of a quadrilateral 180 degree, that quadrilateral is cyclic. That is why I told you what we have to do. Two angle. Vertex or one angle, vertex cycle or circle. That 2 angles of a opposite angle, if the sum of pair of opposite angles of a quadrilateral is 180 degree, the quadrilateral is cyclic. Now please do example 1 to 5, 126, 125, pages 126 and 127. Question example 1, 2, 3, 4, 5. Without looking answer given. Dear children, don't look the answer, please. Look the question and check the answer last one. After doing question 1, you can check the answer. Then question 2, believe me. നല്ല കുട്ടികളായിട്ട് അങ്ങനെ ചെയ്യും. സാറ് നിങ്ങൾക്ക് തോന്നാ 1 to 5 ഏതായാലും നോക്കാം സാറ് പറഞ്ഞല്ലേ ആൻസർ വിത്തൗട്ട് ലുക്കിംഗ് ദ ആൻസർ. യെസ്. അപ്പോൾ പേജ് നമ്പർ 126 127 നല്ല കുട്ടികളായി മറിച്ച് നോക്കിയിട്ട് ചെയ്യും. എന്നിട്ട് വളരെ ഇമ്പോർട്ടൻ്റ് ആയിട്ട് ക്ലാസ് 9 ചാപ്റ്റർ 9 എക്സസൈസ് 9. എല്ലാത്തിനും ആദ്യത്തെ ക്വസ്റ്റ്യൻ വളരെ എളുപ്പമാണ്. ഫിഗർ ഇസ് ഗിവൺ 10.36. ഇതാ nothing is there. 3 points on a circle with the center O. BOC 30, 60. D is a point in the circle other than the arc ABC. Find ADC. അത് സെറ്റല്ലേ? ഇതാർക്കും ചെയ്യാം, ആർക്കും കണ്ടുകൂട്ടി ചെയ്യാം. യെസ്, ABCD സൈക്കിൾ കോർഡിനേറ്റിൽ ഒന്നും പോവണ്ട. വി ഹാവ് ദ ലോ. ഇവിടെ AC ഇതല്ലേ ആർക്ക്. ആർക്ക് സെൻട്രൽ ആംഗിൾ എത്ര? 60 + 30. ദാറ്റ് ഈസ് ഇക്വൽ ടു 9. അതല്ല ഇപ്പൊ ഇതുവരെ നമ്മൾ പറഞ്ഞ വാല്യൂ. ഇവിടെ എന്താ? ഒരു ആർക്ക് തന്നിട്ടുണ്ട്. ഈ ആർക്ക് സെൻട്രൽ ആംഗിൾ ഉണ്ടാക്കുന്നത് എത്ര? 2 ആംഗിളിനുണ്ട്. ഇത് എത്ര? 90 ഡിഗ്രി. അപ്പൊ റിമൈനിങ് പാർട്ട് ഓഫ് ദ സർക്കിൾ ഈ ആർക്ക് എവിടെ ആയി കഴിഞ്ഞാലും കയ്യിലെ റിമൈനിങ് പാർട്ട് ത്രോണ്ട് 45 ഡിഗ്രി ആയിരിക്കും അല്ലേ? കാരണം ഇത് സെൻട്രൽ ആംഗിൾ അല്ല, സെൻട്രൽ 90 ഡിഗ്രി. എവിടെ വന്നാലും 45. ഇനി ഇങ്ങനെ കൊടുക്കുക, നിങ്ങൾ ബേജാറാവണ്ട. അങ്ങനത്തെ ക്വസ്റ്റ്യൻ ഇതൊക്കെ 45. ഭാഗ്യത്തിന് ഇവിടുത്തെ ക്വസ്റ്റ്യൻ ഇത് മാത്രമേ ഉള്ളൂ. ഇത് എത്ര ഉണ്ടാവും? 60 + 30 90. സോ ഇറ്റ് വിൽ ബി half of 90. That means 45 degree. Answer കിട്ടി. Then angle ADC, that is equal to 90/2. That means 45 degree. ഇതുവരെ മനസ്സിലായി എന്ന് കരുതുന്നു. ഒരുപാട് കാര്യങ്ങൾ എക്സ്പ്ലെയിൻ ചെയ്തു. നമ്മൾ മറ്റു കാര്യങ്ങൾ ഇനി ക്വസ്റ്റ്യൻസിൽ കണ്ടില്ലേ, ആ ക്വസ്റ്റ്യൻസ് എല്ലാവരും ഒന്ന് നോക്കി. ആഫ്റ്റർ 9.3 ഫസ്റ്റ് വൺ ഐ ഡി, സെക്കൻഡ് വൺ വളരെ ഈസിയാണ്. തേർഡ് വൺ, a quarter of a circle is equal to the radius of the circle. ഓക്കെ, ഫിഫ്ത്ത് വരെയല്ലേ വളരെ ഈസി, ഒന്ന് ചെയ്യാം. അതിലെന്നെ മാർക്ക് ചെയ്തിട്ടുണ്ടോ എല്ലാം ഈ പ്രോപ്പർട്ടിയാണ്. അതിൽ ബി കെയർഫുൾ, ചെറിയൊരു ആംഗിൾ ഒരു ട്രയാംഗിൾ കാണുന്നുണ്ട്. റേഡിയസ് ആകുമ്പോൾ ഐസോസിലെറ്റ്. ഓക്കെ, ദെൻ പഠിക്കുക നന്നായിട്ട്. ഓൾ ദ ബെസ്റ്റ്. ബൈ ബൈ.